Google saying it's the same of the actual security that we provide. So that's why I'm coming to conferences because we want to tell the world that yeah, we know what we're doing, and we really try really hard to help people to make sure that the data that we're hosting are safe against all kinds of attackers. So this is basically our philosophy, if you can call it that way. So we found that security is trivial if we don't care about cost, if we don't care about usability, if we don't care about developer productivity, or we don't care about time to market. Like if it's okay for us to take 10 years to develop any products, then we can make sure that it's safe against all sorts of attackers. For example, if we don't care about battery, if we don't care about memory, if we don't care about CPU time, buffer overflow would be a sole problem. We can just put every code in 3 layers of virtual machines, and if 3 doesn't work, we would use 4, 5, or 10, and there is no way for anyone to hack us anymore. But nobody would use our products anymore, and we would go bankrupt very, very, very soon. And that's not the outcome that we want. So, of course, we care. We care about cost, we care about usability, we care about productivity, we care about time to market. And I think this is something that I want to emphasize with the research community, because I saw lots of research that don't care about these things. And that's why we can't use them. So, we want to make sure that our products are safe. At the same time, we want to make sure that it consumes less memory, it consumes less battery, it's useful, it's easier to use than our competitors' products. So that's why this is very interesting and important. So I think we gather here, everyone here understand the importance of security. But I think security is usually what sits between users and what they want to do. So users want to read emails. They don't want to sign in. They don't want to be mailed with that password that they said like 3 years ago. Now they forgot about the password. They don't want to enter that CAPTCHA. What's in the CAPTCHA? I have no idea. And that's exactly the question my mom asked me when she has to enter the password. So the question that we usually ask ourselves is not like which security measure, which security checks that we should add into our products, but which security checks, which measure can be removed, at the same time making sure that it's still safe. So we want to make sure that everything is safe as much as possible, but not safer. Like basically, we don't want to make it, like maximum security is for prison, not for products that people want to use. And this is like basically our guiding light. And basically we follow this principle everywhere we go, and I think it has served pretty well. So how do we make it work? This is like the first. Can you see that the first diagram is the software development life cycle, and the lower diagram is our basically 4 components in our software security program. To function at Google scale, we have to make it hard to introduce bugs in the first place. So that's the goal of happening, and I'm going to share more about that later. For what's slip-through happening, like we proactively use low-level, app-level decision defense to make sure that it's very hard for attackers to exploit the bugs in our system. For example, we harden our kernels, we enhance the security of our compilers or the memory allocators, we build and run untrusted code in sandbox or lightweight virtual machines. Why lightweight? Because we care about performance and cost to run these things. We use existing and build new web standards to prevent common web vulnerabilities. We do all those things to make sure that if there is a bug, and we know for sure that we have bugs in our system, it should be very hard for someone to exploit those bugs. We also strategically work with the product teams to scratch, to kill, design, and implementation bugs very early, as early as possible. Because it's much cheaper to fix something when it's still on paper. Like, there are moments that people come to us and ask us to fix something, to look at something, and we're scratching our head and said, why you don't come earlier? Like, this is now very hard to fix. So we encourage people to come and talk to us as early as possible. And we have a very well-functioning, review process where people can making sure that whatever they launch, they get a professional security engineer looking at their things and give them, advice or tell them what the right thing to do. And finally, once the products are released, deployed to the end users, we continuously monitor and kill, eliminate all the bugs that may happen. This is the goal of response and remediation. We also proactively fuzz everything we use. Fuzzing, right? Like fuzzing is intentionally send fault input to a software package so that it crashes, and then we determine the crash to see if it's exportable or not. We run a very, very large scale fuzzing program, and we found thousands of bugs in our own software, our third-party software that we use. So I'll give you a concrete example, Google Photos. This is one of my favorite apps. Its core feature is very simple. It allows users to take photos, record videos, and share them with friends or families who can post comments, like the photos, whatever. It's very simple, right? So when I brought up this example, a friend of mine told me that they can do this in 1 hour. This is so simple. Why you want to use this example? So yeah, I think it's true that you can do this in 1 hour unless you take into all accounts, all the potential security issue, at the same time still making sure that the app is fast and fun to use. So what could go wrong here? A lot of things could go wrong. So this is the question that we asked during consulting. Basically, the first thing is we don't want users, anyone but the user and the people who are shared the photo with, have access to the photos and videos, right? So we want to make sure that the data is not leaked to anyone, either during transit or in motion. And then the asset control system needs to make sure that it only gives people with access, with permission to access the photos, the data. But it has some interesting problem, something we call the X-FAN problem. Basically, if you look at this comment, this photo I have with my friend, I share an album with him, and then, for example, I share an album with him, and then I remove this access, and then I add new photos to the album. At that point, if he signs it again, it's okay if he keeps seeing the old photos, but it's not okay for him to see the new photos, which are not shared with him. So this sounds like a very trivial problem, but it's actually very hard to do at global scale because the user can come from anywhere in the world, and we don't have one single server, right? We have 100,000 servers. So how do you make sure that all the servers all over the world have a consistent view of the app at the same time? And this is a very, very hard engineering problem. And the photo apps is available on web, on Android, and iOS. And all these platforms have specific, issue, platform-specific issue, or security defects that we have to constantly keep in mind when we develop, apps on these platforms. For example, on the web, if you allow any user input, you have to take care of cross-site scripting. And you can see in the photo, I have a comment, which is look like a normal comment, but it actually allows me to execute JavaScript. And if my friend view a comment, I can run JavaScript and extract all of his private photos, which is pretty bad, right? So we don't want that. And then the user upload videos, and to save bandwidth and storage cost, we usually re-encode the video. And to do that, we need to pass the video using C and C++ parsers. And you all know that if you do that, you would want to go to memory corruption, because basically the effect of life. When you use the C API string API, you would have buffer overflow in your code. So there are lots of problems, and this is just the beginning. Like the products involved over time. Like after we finish all of these things, the product team come back and tell us that, oh, we come up with a great idea. That user would love it. And can you help us to make sure that it's safe? And the idea that they came up with is, in some countries, data plan is very expensive. It's not even Vietnam, it's very super cheap. So, and user want, like, for sharing data, they want to do the peer-to-peer sharing. Like, if I'm sitting next to my friends, it doesn't make sense for my friend to upload the video to Google, and I have to pull it from Google, and it costs me like a few bucks to do that, and it doesn't make any sense. Why can't we just transfer the data directly from one phone to another phone? And that brings its own set of challenges, right? Like, how do we, ensure the connection between the two phones, the security of that connection? How do we identify who is the sharer? How do we know that